All right. We are running a little bit early, actually. I think that's okay. I think we're going to just move into the next talk, and I'm going to bring Puya into the chat now. Let's see if he's here. Hey,
Hello, can you
how
hear
are you?
me?
How are you doing? Yeah.
I'm doing all right, thank you very much.
Welcome. Where are
Thank you.
you? Where are you calling in from?
I'm calling from Auckland, New Zealand. Right now it's 4:42 here, beautiful day, and I'm
Amazing.
right in the office, so I'm gonna do the presentation, go back to work, and come back with a QA, and yeah,
Perfect. Okay. Are we gonna
pretty.
get some background visitors from your coworkers or anything like that?
No, no, no. If I was sitting the other way around, you probably would, but I'm facing the monitor. But no, you're not gonna get any background.
Great. We are we're a little bit early. Are you okay to get started?
Yeah, why not? Let's do this.
Okay, that sounds good. Let me. Maybe you can introduce yourself. I know that you're a software engineer, data scientist, and that you're going to be talking about event-driven engineering and why it's probably
Yeah,
a good idea for a
cool.
lot of people, which I actually find to be a really interesting topic because it's one that I think in web just does not get. It's not a tool that's used as often in web development as you might see in other platforms. Um,
Yeah, yeah, that's true. So to introduce myself, my name is Poya, as you can see, and I work as a technical lead of a company called EasyBet in Auckland, New Zealand. We have this practice management software, very huge one. And other than that, I'm a researcher. I'm doing a PhD right now, so I take part in a lot of academic conferences and also other conferences like this, which is a place for me to sort of get more knowledge and share insights and all this kind of stuff. I find every opportunity to learn, either through books, conferences, or audios, or anything else. And the reason I'm here today is to talk about event-driven architectures because I am designing probably the first microservices event-driven architecture for the big data world, and there have been challenges I've been facing, and I've done this at work as well. And because the conference is called Case Study Festival, I have a very good case study to talk about today to let you know that how you can make a very bad architectural decision and cost you and your company thousands and thousands of dollars. So if you're
wow.
ready, let's get
Yeah.
into
Do you
this.
have some slides that you want to share?
Yeah, sure.
Okay.
So as I take over, you can always stop me if you find any kind of technical challenges, like if the slides are not correct or if my voice cuts off or anything like that.
Sure.
Please just
Yep,
let
we'll
me know.
we'll we'll let you know.
All right, cool. One of the problems right now that I have is that I hear myself echoing. I'm not sure why that's happening.
Oh, interesting. I do not
Just
hear an echo.
okay. Maybe it's better now. All right.
Okay.
Now, yeah. Let me share.
All right.
Can you see my slide?
We can. They're up.
All
All right.
right. Oh,
Take it away. The
all
floor
right.
is yours.
Cheers. Let's do this. All right. So today, first of all, before getting into my topic, I have not been listening to other topics, and because I've been working since this morning, and the conference started yesterday for us at 11 p.m. So I never had a chance to sort of get my head around what people are talking about. But I've been listening to the previous speaker about testing and stuff, and pretty cool stuff. The topic that I'm about to discuss is more architectural. Um, I'm going to go through and explain to you what event driven actually means. There is a lot of fallacy around the definition of event-driven architecture and how people actually perceive it and how actually people implement it. And then from there on, I will give you a good example of what problem we had and how it solved us. And I'll give you an example of 2 companies, actually. All right, let's get into it. So the first question is, what is an event-driven architecture? So let us think about, and this is where things get really interesting. I like to bring about the most simple analogy that I can think of, and that's the analogy of a restaurant. Think about a restaurant, and in a restaurant, there are different kind of elements, different people handling different kind of a job. One person is in the kitchen, one person is the waiter staff, another one's getting orders, another one's trying to make sure that everyone's happy, and another one's is stock keeping, another one's doing finance. And all these elements needs to communicate with each other in order to achieve the common goal of the restaurant, which is operating efficiently and bringing profit. So we have, for example, Mary, and Mary has to talk to Alex. Alex has to talk to James. James has to talk to, I don't know, Lagatha, and Lagatha has to talk to Bion, and Bion has to talk to Mohammed, and Mohammed has to talk to Sanchez, and all these nodes. I think you know what I'm talking about. And all these nodes need to find a way to communicate with each other. So the very trivial and a basic method for them to sort of communicate their needs in order to achieve the purpose of the restaurant is through a direct point-to-point communication. And that means as soon as I get an order, I go to the kitchen, I tell the guys in the kitchen, hey, we got this order, you gotta make that food, we need the chicken, and the chef goes around and talks to the other guys and kitchen hands and tell them to chop the stuff or do other things. And they will go ahead and do that. And those guys will come back to the chef. It's like, this is ready. Chef will come back to the guy and he will say, okay, the food is ready. And then the guy will bring back the food and give the food to the clients and customers. The communication would look like this. Every point would have a kind of a dependency on another point, and they all have to communicate with each other. So this is what you will get as a communication channel. You see, all those points are now somehow connected to each other. This is a little bit chaotic. And if you think about this analogy in a software universe, and if you take Alex, Alan, Bion, Lagarth, and all the people that I told you as computer nodes and architectural constructs and modules, you will soon realize that this will go out of hand. So how can we solve this problem? Event-driven architecture. That's how we'll solve this problem. Event-driven is all about communication. In fact, one of the very important factors that brought up event-driven architecture, when I say brought up, pay attention to this brought up phrase, because event-driven architecture is not a new thing. It's been around for 30 years. My supervisor, who's in LA, who's a doctor at AUT, Oakland University of Technology, he knew about this 25 years ago, before even he started coding. So event-driven architecture is not a new thing. And the fact that it's now came back to the scene and it's been hyped, one of the very important reasons is the increasing complexity of the systems. For instance, microservices. Imagine Uber having 2,000 services, 2,500 services, and applications needing to communicate with each other. Well, a restaurant is a very, very contrived example, of course, but you can think about a very more complicated communication scene and communication scenarios. And this method, point-to-point method, will soon fail you, and it will fail you miserably. And you really don't want to scale this. I'm telling you for sure. I've been there, I've done that. So point-to-point communication is not the way. So to solve this problem, we will create an event-driven architecture. And this is very subtle. You see, in the current scenario, A has to go to B, and they have to communicate point-to-point through a command philosophy. And what I mean by a command philosophy means A will let let B knows that, hey, I want you to do this thing, or I expect this thing from you. And this is the command philosophy. This is exactly making an API request to another service and waiting for that result to be resolved, which is something we do every day. However, in event-driven architecture, we do not go directly to the other node or let them know or command them for what we need, but we sort of react to a change of a state or to an event that has been dispatched. So all I have to know in that stage is that I need to dispatch this event and forget about it. Coming back to the restaurant again, I received an order, I put it on the bench, and that is not my responsibility anymore. I forget about it. And then the chef will pick that up and react to it. So if I want to define event-driven architecture, I would say it is a method, an architecture in which you would like to make reactive nodes that are independent of each other. The end result will look like this. We have the very same nodes in the restaurant, same people. I forgot the contract names that I made up, but you can imagine A, B, C, D, E. And now, instead of them going to each other directly and commanding each other for what they need and for what they don't need, they will all go through a mechanism or an event backbone or a message broker, if you will, in order to get the things done. So me and you and Alan and Peter, we do not have to talk to each other directly, but we will, as soon as we leave the paper on the bench, we will know that everybody else has to react into that. And it doesn't mean that you have to react to every paper that I put on the table or the bench. You can react to something that is related to you, and that's where the topic comes up. So I have the topic of making food, and on that topic we have the chef, and we have the kitchen hands, and we have the waiter staff, and all these stock keepers, and all these people working on it. And then we have another topic which is about financials, which is only about the waiter and the front of a house. So this is scalable, and this is elegant. And going down this path, this means if I had to remove Peter from this organization or from this restaurant, I don't have to worry much, because James does not know about Peter at all. I mean, they see each other, of course, but they go through an event bus. All that James knows about Peter is that Peter dispatches event that I have to listen to. So as soon as the Peter dispatches an event, I will listen to that, and I will get the job done, and I will dispatch another event which somebody else will pick up, and so on and so forth. And this happens in the order of dispatch and forget. So I don't want to wait for you to give me something. I don't have to affect all the other services based on how much you're going to block me and all this kind of stuff. And one of the areas where this really shines is microservices. And we all know about microservices and micro frontends these days. And you know that the most challenging thing in microservices is the actual communication between nodes. And it is very easy to create a monolithic microservices, which is even worse than the actual monolith. So you have to be very careful on how much dependency these elements have on each other. So coming back, I would like to reiterate the philosophy behind this matter. The philosophy is simple. Instead of A commanding B, we are having the event philosophy. A dispatches an event, and B, C, D, or whoever else you'd like to design for it, will listen to that event. In other terms, we all react to an event or a change in state. Yeah, this is what I talked about. I think I should have changed those slides earlier. So why? Why should we go? First of all, sorry for that slide. I made these slides like minimum amount of time. So the question is, why we should go down this path? This path will give you a lot of advantages. Imagine you will have a lot of nodes and services that sort of need to get the job done, and you would like to extend or modify one of them. And one of the biggest worries of the software engineering universe is to introduce side effects and break things, and that will stress us. Even if you've written very good tests, you're still prone to failure. And the amount of effort and time it takes you to extend and modify something is a lot if you have a monolith, or if you even have services that have communication problems. You may have 500 is a big number, you may have 120 microservices or micro frontends, but if the communication is broken, the whole system is suffering. I'll give you a very simple scenario. You have node A listening to node B, and node B not listening. You have node A communicating to node B, and as soon as node B gets the job done, it has to call node C, D, and E. So what happens is that if node B is slow in processing that request, it will affect all the downstream nodes. And as you go and as you add more things into this kind of a monolithic microservice architecture, you will soon fail, and you will have terrible headache, and you will have the overhead that will become very expensive to maintain. So why you would go event-driven architecture? Because once you go down this path, the right path, which is difficult, all it takes you to add something or remove something is basically removing the module. So if I had two modules listening to a certain topic and reacting based on what they listen to and what they get, if I remove one of them, this has no effect to the other parts of the system. If I wanted to, on the other hand, add more functionalities to the system, I can chain another event, which is dispatched by another service once the success result is dispatched from the prior event. So this sort of works together. I will show you common patterns to event-driven very soon in the next few slides, and this will be very clear for you on why and what's the gain. But every time somebody asks you why event-driven architecture, you would say modularity, modifiability. I'm not even pronouncing that. I have a trouble pronouncing that, modifiability or something like that, ability to modify whatever you take, and extendability of your applications. But at the core of all of this is communication and very different kind of philosophy to how you do things. So how did I do this, and how it helped me, and in which area I use this? So before coming to EasyVet, I was working for Vodafone, and Vodafone, as you guys know, is a big telecommunication company. So in order to do analytics in that company, we cannot use third parties. Security is a very important thing, and we couldn't just sort of add one of these third parties and have a script and load that script, which will read all the events and register it in the third party server. We couldn't do that. So we had to create our own analytics system, and I was a part of that. And what we've done was that we created custom events. We created custom events in JavaScript. You can create custom events, and you can dispatch custom events. And we sort of, in different places, we capture different data based on the categories we defined. So for example, if you clicked on, you want to buy a mobile phone, so we dispatched it even with a category of mobile phone and the color you've chosen and the brand you've chosen and all those sort of things. And as soon as you dispatch that event, we had a listener which would listen to that, would get that data and update it in our data layer. How the data layer happen and all of that is outside of the scope of this, but going event-driven, all we had to do was just basically creating 3 helper functions and calling them everywhere. And so we just called our dispatcher in where the click was happening, the event was happening. And we just gave it the category and the data that I needed, which was in the state of that component. So we didn't even make our state more complicated. Another thing is complex states. So here in EasyVet, we probably have one of the most complicated financial tables. We cover a lot of scenarios. Let me just quickly check. How much time do I have so I don't go and talk all day? Okay, still good. Sorry. I think I have to come back to the slide and okay, amazing. It's just okay, complex states. See, I was saying that how we have a very complicated financial table here, and one of the challenges was that we had to do lots of complicated financial calculations, and we also had to take care of permissions, departments, and we had to take care of complicated things such as discount rates in different countries, surcharges, and all this kind of stuff, tax rates. And we had to sort of configure, we had to fuse all these things together. It was the amalgamation of very complicated things that had to communicate with each other, and they all play part in the final state of, for example, one cell that we had, which could be edited or could not be edited based on where you were and what kind of privileges you had. So this is very interesting. So there are 3 ways you can solve this problem. The first one is what I would call the naive way, which means you basically have a Redux state, and in the Redux store, you store everything, and you will get privileges, you will get financials, you will get departments, you will get all these things, and then you will have these helper functions which will resolve one area and then call another helper which will resolve the other area, and then so on and so forth, this point-to-point thing that I talked about. And then you will have one final helper function which you will call inside your component, which will eventually decide the state. This is hard to test, hard to maintain, very hard to work with, and almost everybody stressed about working with this bit because every time we touched one part of it, something else failed. Well, I wasn't there when this was implemented, and it was suffering from some of the fundamental architectural problems. And one of them was this, the naive way. The second way, second way of solving this problem is something we haven't done, but it's imaginary. If you had a good computer science background, you know about data structures, you would create I would create a binary tree, and then I would have these as nodes. So each cell is a node, and then I would implement an observer pattern which would listen on these nodes and will select, and we would say, based on what data they get in correlation to other nodes, it will decide the state of that components. That's exactly what is React doing behind the scenes with fiber nodes, just creating 3 of them. And I like binary trees. I think they're very good way to solve problems. And this would also decrease the runtime complexity of getting the value. For example, if you have like 100 lines in a financial table, you want to get all the discounts of it. I think binary trees would really be fast because you can get a biggest value just going by just getting the left nodes. The best way from my point of view is through the event-driven architecture. So instead of these helpers talking to each other, updating each other, and calling each other, you would have these cells react to a mutation of a GraphQL. Basically a client-side GraphQL schema, which will mutate, and to which all these cells will react. And when I say all, it's not very accurate because different cells will subscribe to different stuff and listen to different stuff. If you're doing pub/sub, or if you're even doing mutations, different cells will listen to different topics, and they will, not topics, they will listen to different pieces of your graph and react according to that. And plus you have these fragments, you have a very declarative query API, and things are very clean and amazing. That's the second example, which was a reality of what we've done here. And the third one pretty much covers what I talked about, which is the mutation heavy stuff. And I think one of our challenges was choosing the wrong data type as well. If you're doing advanced asynchronous programming, you should definitely check into reactive programming with observables, especially if time is a concept for you. So, observables are the data types which take time into consideration. And that's a very important concept if things get complicated. So they are literally collections over time, and that will give you lots of tools to handle lots of problems of asynchronous programming. So definitely check that out if you have a lot of asynchronous problems. And fun fact is that React itself is not reactive. So that's a little bit of a poor naming because in React you'll have to update the state yourself, and nothing is literally reactive. Svelte is, on the other hand. Not getting so far away from event-driven, coming back to it, I give you a few examples of a real-life problem. So in the event-driven kind of a universe, there are two approaches to this architectural kind of endeavor. One of them is choreography, another one is orchestrated. So let me explain to you what does it exactly mean. If you take the event bus as a music, your services are kind of dancers who know what to do. Like A knows to dance like this and B knows to dance like that. They just listen to the music, which is the topic, and they literally know what to do as soon as they listen to the music. When we speak about event-driven architectures, we are really talking about this music thing. You just play the music and everybody knows what to do. If you take somebody out of that group, the group functions. If you add somebody into the group functions, as long as you hear the music. However, there is another approach to it, which is the orchestrated approach. And the orchestrated approach is more about, to give you an analogy, you can think about an orchestrator or a conductor who's, the conductors, right? Who's like sort of leading a musical group. And if you have in this room 50 musicians and you want to sort of orchestrate them, you may be able to do it. But if you have thousands of people and musicians from all around the world, then the orchestration or conductor thing is not going to work out. So orchestrated may have its use cases, but from my point of view, you may want to avoid it as much as you can. Because orchestrated means that you will have one node which is responsible to make sure that the transmission or communication is complicated. Not complicated, is finalized, and sort of the node is in control of making sure that the communication from A to B has happened. It's sort of orchestrating the process, if you will. What are the best applications of the event-driven architecture? By applications, I mean, what are the best profits? Actually, no, by applications, I meant the applications, but I talked about it already. But one more example, which is very interesting, is about the big data universe, which is something I do for my research. And in the big data, we have stream processing and batch processing and all this kind of stuff. Event-driven architectures, especially with Kafka, will help you distribute this stuff to kind of different service meshes which have their own control tower, which will handle everything. Not to digress much from React kind of universe, but it has applications everywhere. So next time you want to think about React and real scalable front-end applications, think about the architecture. Please do this yourself and save yourself and the company and the team and everybody a lot of headache. Just do the design docs, come up with. You can learn about Archimate, a model language that will help you take down your brain. And the gain is a lot, because architecture, like every system has an architecture. Either you know it or you don't know it, your application has an architecture. Known or not known, there is a pattern to it. And either you make it, you manifest it and you try to work on it, or it will lead you and you don't know what is going wrong. So please take the time to architect things. Don't just jump into the code. Think about what you want to do. Think about what the problem you're trying to solve. Think about your resources and try to get them together. And be very careful of your dependency. And nothing is more expensive than a bad dependency. Be very careful with third-party packages. You don't need Lodash. You don't need Moment.js. You definitely don't need Material UI. These are bad, hefty libraries. And every new library, just go check the code and make sure that everything's okay. These libraries, third-party libraries, from my point of view, are flooded with bad practices and inefficient code. That's not related to event-driven architecture, but just want to let you know about how does it work. And how do I work, sorry. And don't make your components or anything very reliant on each other. Try to make things that can stand their own. Try to decrease dependency as much as you can. I will repeat myself. Make reactive, decoupled components. That's the aim of a front-end developer. And as a front-end dev, your aim should be 200 kilobyte of JavaScript, 100 kilobyte of CSS, and as fewer input requests as you possibly can. I know this is a crazy number, but always check your JavaScript usage. You should at least use 85% of the packages that you ship to the user. And if it's something lower than that, then something's wrong. I think everything that I said kind of covers what is being shown here. And that's, I think, the most beautiful slide that I've created as well. So let me quickly go through it once more time. Decoupledness, of course, extendability, of course, just add a new service. The music thing, I think, makes a lot of sense. Add people, remove people. Everyone's dancing. Everyone's happy still. It's like a club, night bar. Scalability, yes, of course. You can scale very easily. Just dispatch events, listen to events. And it's also far less headache. And we can lead the team easier. Everybody that we have here as well, people will have less stress. It also has better performance because you don't have a spaghetti. And the spaghetti is literally, like the point-to-point communication that I told you about is literally the spaghetti of software engineering. One function is going to another and another going to this, and this is like you change this bit and then everything else is affected, and it's so hard to understand, and people are very bad with naming, and yeah, I think you know what I'm talking about. And failure handling, cool. Failure handling is also very important. So writing as front-end devs, we don't care about retry mechanisms much, but I think they are worthy of mention. Once you go event-driven with Kafka or something like what we've been talking about, the message brokers like any message or like EventBridge, you will have an automatic failure handling kind of a thing built in out of a box. That will come as any kind of message broker or even backbone that you use. Okay, thank you for your attention, but I will also have to talk about the disadvantages of event-driven architecture. One of the disadvantages is that debugging is way harder. So there are actually approaches to solve that problem. One of them is called the contract-driven development. And I think that's all. Thank you guys for coming around and listening.
Thank you. That was great. We have a couple questions that have come in. Do you have time for a couple questions?
Yeah, no worries.
Okay, great. So one here is from Mark in the chat, and he asked, how do you handle entities, nodes, where like if they fail to listen or act on a given event? How do you handle that if all the events are just transient data?
So that's actually a very good question. So the retry mechanism I was talking about is something that you can set up in Kafka or any other kind of a message broker or even backbone you're using. Kafka's got a best support for it. You will want to use out-of-the-box failure mechanisms, or you can create your custom ones and you can define a threshold for it, for what you want to happen in case that node fails to listen to something or another node fails to dispatch something. But the thing is that, for example, in the case of Kafka, it will keep this in a node in the event archive, and if that node failed to listen because of network problem or something like that, once it health checks. So once it comes back and the node is up, then it will take it out of the event archive and let the node listen to it again. It can get complicated though, but in a most simplified way, I think this is the answer.
Okay, that's great. Another question for you. What do you, on web, I know with a lot of events, browsers are picky as to when you can fire native requests to the browser. Like certain like changes to play a video, for example, have to happen within a click event and those sorts of things. And so how do you manage like synchronous events through an event bus on web? Have you had to deal with that, or have you had any experience dealing with synchronous handling of?
Well, I think synchronous events are not very complicated to handle. You just literally have to understand the web APIs and sort of go according to the rules. The JavaScript is basically all about events. And yeah, I don't like, if you give me a very clear example, maybe I can give you a better answer to that. But
no, I mean, maybe it doesn't. Maybe it's pretty straightforward. I mean, in your practice, are the event buses, are they usually events fired and then handled all synchronously, or is that like an asynchronous event?
So it's asynchronous in terms of the node that is dispatching it, and it's synchronous in terms of the event backbone, and it's also asynchronous again in terms of the node that is listening to it. But it's entirely up to you on what is the best performance for you for the combination of nodes and what you like to keep synchronous and what you like to keep asynchronous. But once you're asynchronous, your problem is doubled, and you have to make sure that you handle asynchronous things very well. And concurrency is one factor. Another factor is choosing the right data type, like observables, for example.
Got it. Okay. Well, that's great. We actually, I mean, you're going to be back with us for some more questions a little bit later.
Yeah, sure.
Okay, great. So I'll we have a handful of them here, and we'll get back to these. So thank you for this. Thank you for your time, and this was fantastic.
Thank you.